12.2, analyze arithmetic sequences. Arithmetic.
Oh.
In an arithmetic sequence,
I think this happened last time too. I couldn't see where your eye was. Because your eye and your arm are like connected.
the difference of consecutive terms is constant. This constant difference is called the common difference. And is denoted by the letter D. The rule for an arithmetic sequence, and there's a couple different ways we can like write this rule, but this is the one that we're going to use for the sake of like this class, and then next year you'll learn like one of the other options as well for how to do it. The nth term of an arithmetic sequence with the first term being a sub 1 and common difference D is given by a sub n is equal to a sub 1 plus n minus 1 times D, and the other option is a sub n is equal to a sub k plus n minus k times D. Now, the difference in the top and the bottom one is for this top one, we have to be given the first term. The bottom one is that we can use any term to start with. So like if they said like the third term in the sequence is this and the common difference is this, then you could use this like piece of information to find whichever term that they wanted you to find. So when we have an arithmetic sequence, we have a set of numbers, okay, like 4, 8, 12, 16, 20, 24, something like that, where we're constantly adding the same value to the previous number to get the next one. So these first couple problems are just going to have us state if it is arithmetic or not. It says to like say why if it's, or like for either like why or why not. I'm not so much worried about that. I just want you to, if it is, tell me what the common difference is so that you're like recognizing what that would be. So number 4, we've got 16, 14, 11, 6, 3. And these keep going on, obviously, but we're stopping there. So it wants us to look and see if this is arithmetic or not. So how do I get from 16 to 14? Subtract 2. How do I get from 14 to 11?
3.
So is that arithmetic? Nope. So I can stop as soon as I see that it's not. It has to be the same thing the whole time. Eight. 20, 10, 5, 2.5, 1.25, ...
Divided by 2.
Common difference is adding or subtracting. So is this arithmetic? No, this is going to be the type that we're going to learn tomorrow. So this is not arithmetic, okay, because the first time I subtract 10, the next time I subtract 5, then I subtract 2.5. So yes, it is dividing by 2, but that's not what it means to be arithmetic. So this one is not. Um, 11. Negative 5 halves, negative 1, 1 half, 2, 7 halves. So I chose this one because it's kind of weird. So how do I get from negative 5 halves to negative 1?
Add 1.5.
Add 1.5. How do I get from negative 1 to half?
1.5.
So is this arithmetic? Yep. So we would say that, and then we would say D is equal to either, you can either write it as 1.5 or 3 halves or literally 1.5. Either way is fine. And if it was, say, in reverse where we were subtracting, we would just put a minus sign on there because arithmetic is either adding or subtracting to get there. Okay, the next one's write a rule for the nth term of the arithmetic sequence, then find a sub 20. So number 12. 1, 4, 7, 10, 13, ...
Yes. Because you're adding 3.
Yep, so that means that our common difference is 3. So I'm adding 3 each time. So we're going to use the information that we have here to write our rule. Now, usually I put the common difference value in front just because, I don't know, I don't like the distributive property being backwards, but that's just me. So our rule is going to be a sub n is equal to our a sub 1 value, so that's going to be 1, plus the common difference, 3, times n minus 1. Now, this is technically the rule. The book, in a lot of cases, goes ahead and distributes this and combines the terms. I wouldn't do that. I would just leave it right here. Okay, so just leave it like that and get the value that way. So now if I want to find a sub 20, because that's the next step that it wants me to do, a sub 20 is equal to 1 plus 3 times, we replace n with 20, minus 1. So then I just have 3 times 19 and then plus 1. What would that be? 58. So that means that a sub 20 is equal to 58. Now, let's just say that hypothetically, you get to the quiz and you forget how to write the rule, okay? These questions are obviously twofold. You have to write the rule and then you have to state what a sub 20 is. Could you find a sub 20 without the rule?
Wait, yes.
Yeah, I just keep adding 3. So this is my 5th term, so then I could say, okay, well, my 6th term, 16, then 19, then 22. You're just, obviously, if it's a sub 20, you're going to be adding out for a while. But you can find it that way, and that's another way you can just check it, is to go back and do that. The rule just makes it faster.
Is it a sub 20, like from 1 or from the last number we have?
It's from the first. So, like, this
Okay.
is a sub 1, a sub 2, a sub 3, so on and so forth.
So it doesn't start.
So it just keeps going all the way out till you get to a sub 20 is what we're trying to find.
Okay.
Normally, like, in the pre-cal book, it's like find a sub 8 or something like that. Like, it's not, like, sending you super far out, but this one just, they're trying to incentivize you to use the rule by choosing a really big number. But I'm just showing you that if you forget how to write the rule,
There's still a way.
there's a way to still get at least half the credit right on the problem. So, 14, 8, 21, 34, 47, 60. Anyone want to give it a shot at how to
You're adding
write this?
13.
So our common difference is going to be 13. So how would I set up my equation here?
A, and then the n equals 1 plus 13 parentheses n.
It's not 1.
Oh.
Yeah, so whatever your
8,
first term is. Yep.
oopsies.
So 8 plus, keep going.
13 parentheses n minus 8.
Nope, that is a 1.
Oh.
That's always a 1.
Dang it.
If we're starting with the first term, that's always a 1. If you really wanted to, I could show you how to start with the term other than the first term and how to do that, but if y'all are content with this. Yeah. The formula, that's always a 1 in there. And then a sub 1, that's why this one was kind of a trick question, because this one started with a 1, so I had to look at the formula to see. So this would be, again, that's where you would stop for that. Now I need to find a sub 20.
Equals
So a sub 20.
13, 20 minus 1.
Yep. So we've got 8 plus 13 times 19. Might want a calculator for that one.
It's 247.
Two
No, it
55?
is not.
255.
It is.
God.
Which is 247 plus 8. Bad math.
All right, now, just so that you can see it, I'm going to show you over here how to start with a number that's not the first number, just so that you can see us using the other formula. You don't have to do this way. I just want you to see how to do it. So it's a sub n is equal to a sub k, so that's whatever term you choose to start with. So if I start with the second term, then in our case, I'm going to be using 21, and then it's going to be n minus, it's the second term, so it's going to be n minus 2 now. So it just depends on what you start with. So in this case, we would have a sub n is equal to, I'm going to start with 21. So that's my second term. So then it's plus the common difference, 13, times n minus, because it's the second term, I put a 2.
I see.
And you could plug in and you could do that one the exact same way and you'd still get 255. It's
Okay.
just another way to write it.
What do you
Now, that's going to be important because the problems that we're about to get into are going to require us to basically use this formula instead, because they're going to start you with a different term and you're going to have to use that to set up what it would be and find a certain term. Okay? So with 24, these say write a rule for the nth term of the arithmetic sequence, and then it says then graph the first 6 terms. It just literally means write the first 6 terms. Graph is a poor choice of a word in my opinion, but anyways, don't let graph scare you. So 24, we have a sub 6 is equal to negative 16, and d is equal to 9. So basically, I need to backtrack here, right? I need to work my way backwards. But all I know is the 6th term. Now, can I work my way backwards with just the information without writing the formula? Yes, but we're going to do it with the formula, and then we'll set that up. So we're going to have a sub n. So I'm going to have to use this formula that I had used in the last one in green to do this one. Is equal to, well, I'm going to have to start with the 6th term, so that's negative 16, plus the common difference of 9 times n minus 6, because it was the 6th term. So this would be the way we write the rule. And then it wants me to write the first 6 terms. So I'm going to just put a little space here for each of them.
Would you just move that number, like the n minus 5 and minus 4, or is that not right?
No, this would be the formula, and then you would just plug in. So like if I want to find the 5th term, I'm going to plug in 5 for n, and then I would do it that way. But you can also just work yourself backwards. So I know that the 6th term is negative 16 because they gave me that one. So it just depends on what they start you with. So I need to go backwards and find these terms. So I can either plug in 5, and then that's going to give me a negative 1 times 9, and then add the negative 16. So I'm going to end up with negative 9 minus 16, which is what? Yep, negative 25, so that would be the 5th term. And then what you're going to notice is I just need to keep subtracting 9. It's working opposite, right? Because the common difference of 9 means if I was going to keep going, I'd be adding 9. If I need to work my way backwards, I'm going to subtract 9. So I can either keep subtracting 9, or I can now plug in 4 over here. So I've got 9 times 4 minus 6, so that's 9 times negative 2. Negative 18 minus 16, and that would give me this term. But it's probably easier just to keep subtracting 9. So if I subtract 9, what do I get?
Negative 34.
Negative 34. Subtract 9 again.
Negative 43.
Again.
Negative 52.
And finally.
Negative 61.
Yep. And that's how we would use that to work backwards. So you can either use the rule, or you can just quite literally subtract or add, respectively, depending on what you need to do. All right. Similar 26. A sub 12 is negative 3, and D is negative 7. So they still want the first 6 terms, but notice this time they started me with the 12th term. So let's set up our rule. Anyone want to give that one a shot? Set up the rule.
Equals negative 3 plus 7.
Well, notice it's negative 7.
Oh.
So you can either say plus negative 7, or you can just say minus 7. Either way is fine. I'll just do it like that.
Minus 12.
Yep. So now, notice I'm going to do this one a little bit different. Rather than working my way backwards, I'm going to start and actually find the first term. And then I'm just going to subtract 7 from there. So I'm going to start out here with my spots for my terms. I don't know why I'm making them so large. We'll just pretend that that's not happening. So I'm going to plug in to this formula 1 to find the first term. So a sub 1 is equal to negative 3. I'm just going to say minus 7 times 1 minus 12. So negative 7 times negative 11 would be positive 77 minus 3.
74.
So 74. Now at this point, I can just start subtracting 7, or I can keep using the formula and plug in the numbers. However you want to do it. So subtract 7, we get
67.
again,
60.
again,
53.
next,
46.
and lastly.
39.
What do you think about that?
It's pretty simple.
Pretty easy, right?
Wait, we don't have to go all the way to the 12.
No, it just asked for the first 6 terms.
Oh.
The previous one just happened to give us the 6th term. There's one of them, I think, that gives you like the 4th term, so you're going to have to find terms 1 through 3 and then 5 and 6. So, but even if they give you that, when it asks you to list out the first 6 terms, still include whatever term that is in your list. Don't like skip it. That makes sense. That's why I like to make the spots so that I can write them in. You don't have to like draw little spots, but you know. One more, hold on. I'm looking to see if this was a formula that I forgot to give you or not. Okay, so what do we do if they don't give us the common difference and instead they give us like 2 of the terms? So they say a sub 4 is equal to 31 and a sub 10 is equal to 85.
Trial and error.
Well, there's a faster way than trial and error to figure out what the difference is. Think about, I'm going to say the slope formula. Take that very lightly.
Slope.
Could you,
Like how
find
you
the
have like your
difference?
y2 minus y1 over x2 minus x1, and think about it like that, as if these values that they're equal to are my y values and these subscripts are my x values.
So you need 6
You're out
spots.
of
So I'm going to do
'Cause you would.
85 minus 31 over 10 minus 4.
Yup, this is 9. This is so cool.
9 is so cool.
So 54 over 6, so that's equal to 9. So that's how I would find my common difference if they don't give me the first term or they don't tell me what the common difference is. Like if I don't have a way to find it otherwise, this is what I would do. So then we can write our rule. A sub n is equal to, you can use either of these, so let's just say 31 plus 9 times n minus 4. And that's one, if I wanted to use the other one instead to write my rule, I could say a sub n is equal to 85 plus 9 times n minus 10. And either of those would be acceptable ways to write the rule. So on the ones where I'm given the first term, I often will just use the first term, so I'm just doing like n minus 1 in the parentheses. But technically speaking, if you use one of the other terms to start, just in general, if you're like, I like starting with the third term because 3 is my favorite number, and you wanted to do that every time, you can do that as well, and that would also be a correct answer. Okay? Now, with one like this, you should either use one of the 2 that they gave you. Don't be like, I'm going to go find the 15th term, and then I'm going to use that one. Like, yes, it's still right, but make your life easy. All right, any questions on that stuff?
No.
Should use the other term.
You can do that. Tell me how it's up to you.
5, 9, 15, 23, 27, and 31. So make sure you are paying attention to the instructions of what you have to do for each one, and that will help you. So tomorrow we'll do geometric sequences, which are the ones where things are being multiplied, or if you want to think about it as dividing, we technically say multiplying.
Yes.
Yeah. And then we'll be done.